the inverse of the cosine, and the result is 45, which is exactly the correct angle between the two vectors. Let's use the vector dot product in practice. Let's create a sphere, a cylinder, and the box, and calculate the angle at the sphere between the vectors connecting the sphere with the box and the sphere with the cylinder. We can create a protractor, pick the cylinder and the box as the two objects to be monitored, and align the helper to the sphere. Now we can take a look at the actual angle, which is 50.062 degrees. Let's calculate the same using MaxScript. Let's define object 1 as the sphere 01, object 2 as the cylinder 01, object 3 as the box 01, and calculate the vector 1 as the normalized vector defined by the positions of object 2 and object 1, and vector 2 as the normalized vector defined by the positions of object 3 and object 1. Now we can calculate the angle as the inverse of the cosine function from the dot product of the vector 1 and a vector 2. If we would evaluate, the listener reports exactly the same angle as the protractor helper. We can move any of the objects. Take a look at the angle again, 157.49. Evaluate again, and we get exactly the same result. Another often used vector operation is the vector cross product. The cross product of two vectors results in a third vector which is perpendicular to the two operands. This also means that the new vector is perpendicular to the plane the two operands lie in, and to any other vector that is in the same plane. So if we know three vertices of a face, for example, we can easily define two vectors at the edges of the face, calculate the vector cross product, normalize the result, and the result would be the normal vector of that face. This is why face normals in 3ds Max are typically calculated on the fly by the software. It's just very easy to do. Let's take a look. In this case, calculating the vector cross product would result in a third vector, which would be perpendicular to the two, and its length, it's going to be equal to the area of the parallelogram defined by the vectors. Basically, we translate the two vectors to create a parallelogram, and this area is equal to the length of the vector. This also means that the area of the triangle is half of the length of the cross product. So we are not only calculating a normal vector to the face, we also can calculate the area of that face. Let's try this. Let's take the object as the area 51, just for fun. Take the first face of the object